So project goal is to predict whether batted ball results in a home run using pitch and hit data. So this notebook contains separate sections. Of first section is like data fetching, cleaning and pre-processing. So it uses the PyBaseball library to fetch the session wise data from start up to end session. It also cleans and pre-process the data, like it will filter out the batted ball with valid hit coordinates. It will exclude the burns and the ball which are not resulting in a home run. Like, so these burns ball are kind of intentional tap by batsman, so batsman doesn't swing the bat, so there is no possibility of home run. So these kind of balls are already filtered out from data, making it cleaner and relevant to prediction. So we can see these filters in this notebook, and then once this cell is completed execution, the statcast underscore data folder will be generated with all the session wise CSV files. Then the second cell we will run. Another thing is data cleaning. So in the first cell itself, remove rows with missing values, assign sequential UIDs, and like these kind of filters are applied to make sure there is no missing values, or there is no row with at least one missing values, and there is a one exception. So if 40% around data is dropped due to these filters, then it will throw exception to notify. So second cell is nothing but just combining these files, iterating over. So one second cell is execution is completed, it will generate two files, test and train. So it is 80-20 split, and the split is applied on the combined data set of all the sessions in the statcast data folder. So the next section is data loading, checking and encoding. Once the train and test CSV files are there, we'll execute this, and PyCaret library is used for this cell and the further cells, since it provides the inbuilt pipelines and also allows the configuration to do. So the target variable defined as is HR, which will binary classify 1 or 0, representing whether it's a home run or not. So once we load, we'll see some 5 rows displayed from the dataset. We'll check if any null or missing values are there for train and test files or dataset. Then we'll check for the detailed info on the dataset. What are the type of features if there is missing, and what are count of unique values for each feature. Then there is a graphical representation of dataset displaying the types of dataset. Then there is a correlation matrix which displays correlation among the features being used. Then there is another section, experimentation. So we'll experimented things like different encoding tactics, like one-hot encoding, where there was many binary features were generated for the categories, and it expanded the dataset too much. Then we also tried the target encoding, where only the categories with high cardinality being compressed in numerical values. So we compared the performances of both the encoding tactics, and it was similar. So we chose to go with target encoding, which doesn't expand the data too much and still does the job. The details of on the various models. Comparison. So CatBoost perform in the one-hot encoding, and the XGBoost perform well in the target encoding. Then another test we did on few models like XGBoost, LightGBM, GBC and ADA. So we compared using a smart or not using any imbalance technique, So the results was similar. Then we performed few more experiments, like we compared the baseline models with the model using class weights, then using SMORT and Tomic links combinedly, then regularization and hyperparameter tuning, then like some top feature selection and judging the performances on that. So you can see detailed comparisons of the model for the experiments. Stated the experiment 1, 2, 3. So we found like the class weight model was performing good, but it was not much different with the baseline one. So here is the model comparison chart for based on F1 score and recall. So primarily we are choosing F1 score since it's a good scale for imbalance class data set. It consider both precision and recall. So we can see here in the bar like chart in XGBoost class weight is performing good. So again we tried some sample with baseline and it was found like there was no significant improvement using class weights. So another thing we did is like PCA. Generally in tree models PCA is not being used since tree model are due to the non-linear feature. So tree model are like good to capture non-linear relationships, and using PCA doesn't really help there. So still we just experimented like how PCA changes or degrades the performance of the model. So data visualization, then there is a 1, 2, 3, 4 experiment with the PCA applied. So we just saw like the performance was degraded, obviously because the non-linear capture capability was decreased due to applying PCA. Then we also did some study by dropping some significant columns that we knew. So obviously the performance was degraded too much by dropping those significant columns. So this was also the ablation study regarding the features. So we selected some important features and dropped them and saw the performances of various models after dropping those insignificant features. So it was quite visible that the performance was degraded too much. Mostly the accuracy was high because there was high imbalance in the data set. So they mostly predicted 0 for the data set, and that resulted in high accuracy, but the recall and precision was not good. Then there is a section for final model and selection. So here we finally chose the baseline XGBoost model and trained it with the targeted encoding. There is a heat map generated for the covariance between features. Then we have applied the setup of using PyCaret. So again we are using PyCaret here. So we knew earlier in the experiment that fine tuning wouldn't help, but we still wanted to check. So we applied fine tuning in the model and the result was same, like fine tuning did not improve the model. So again the baseline model itself was taken. Folds are applied to validate and improve the learning capability of model. So once model is trained completely, the weights are saved in the pkl file and top 20 features, and then ROC curve for XGB model that we used. Then there is a prediction percentages. Obviously due to imbalance the prediction of the home run results are low compared to non-home run. Then confusion matrix, so you can see it was like false negatives 17% around, and then we have like metric wise chart. So we can see precision recall, and App1 support metrics for this model. So there is again another notebook which uses this pklb saved weight file and uses unseen data and will predict using that and evaluate the model performance.